Hola estudiantes, hoy nosotros tenemos estudiar chapter 19 about confidence intervals. Okay, so we want to prep for our quiz on Friday, and this is your homework. These are questions that I would like for you to go over. 1 and 9, I think we'll talk about right now too, okay? So let's get started. So in your do now question, one of the questions was, what time do you go to sleep? Okay, so let's say you estimate that you sleep at, let's say, 9:30 p.m. Okay, does that sound reasonable for all of you? So you tell people, you tell friends or whoever, you tell friends, I go to sleep between 9 and 10 p.m. just because you want to be sure. So what you just did right now is you just made what's called an interval. Okay? And in statistics, we want to show how much confidence we have in an interval, in an estimate. Remember, in statistics, we don't like to say exact things. We don't like to say exactly 9:30 because most likely it's not exactly 9:30. So we want to give a range, i.e. an interval. Okay? So if you take a look at page 433 to 434, it's going to talk a lot more about that. The example that they give in the textbook is about C fans. It's at the very beginning, 432. What in the world is a C fan? Anyways, who cares? So it's these, I guess they're like coral maybe, and they sample 104 sea fans in the Caribbean Sea, and they find out that 54 of them are infected, okay, with this disease. So our P hat, what we just observed, remember, this means observed proportion, is 54 out of 104, which comes out to approximately 0.519. So I'm just going over the example in the textbook, so feel free to pause this anytime and follow along your textbook on page 432. Okay? So this is a sample proportion, right? We took a sample of 104 and out of the 104, 54, okay? But what does this say about the population proportion? Say we're a marine biologist and we really want to study these sea fans and we really, really care about them and we don't want them to die off from this disease. Of course, we cannot check every single sea fan in the world, so we take a sample. We took a sample of 104. Hopefully this is a random sample. What can we infer anything about this? Another thing that we need to talk about is population proportion. A term that you're going to see a lot of is true proportion. Okay, so true proportion goes with population proportion. Observed proportion is the same thing as a sample proportion. Okay, because we're not going to get the population proportion, the real population proportion, unless we sample every single sea fan in the world. But what we can do is we can get a sample proportion, because a sample is, remember, it's just that little taste out of that big pot of stew. Okay. If you want to know how to actually answer sample proportion questions, see the sentence frame page that I gave you long time ago. There are copies of this in the back of the room, so you can go back there and get one right now. It's number 6. Okay, it starts off with something like, I am something % confident that something is between something and something. Okay, So in the case of our time one, you could say, I am, I don't know, let's say like 70% confident that I go to sleep, that my sleep time is between 9 p.m. and 10 p.m. Okay. Bonus question for you. What if I change that percentage? What if I change it higher, like 90% or 95 or 99%? What would that do to this interval right here? Would it increase? Would you make it wider? Would you make it like 8 p.m. to 11 p.m.? Or would it get smaller, like 9:20 to 9:40? Think about that. Let's talk about poop. Okay? P-O-O-B. In your do now question, I asked you, I know it's super embarrassing, guys. I asked you because I'm not actually there to see the look on your faces. I just wanted you to feel super awkward and look at each other awkwardly. Okay. On a random note, do you know a lot can be said about a person by how many squares of toilet paper you use? Like when you go number 1 or number 2 or number 3, right? Like you never mind. You think about that, okay? Ask Mr. Jerichow. Maybe he can give you some insight about what that means. The number of squares you use when you're doing your thing, okay? All right, so I want to talk about one of our homework questions. Page 446. It's the very first question. Page 446, number 1. I'll read it to you. Go ahead and turn there, pause the video. A TV newsman reports that results of a poll of voters, reports the results of a poll of voters, and then says the margin of error is plus or minus 4%. Explain carefully what this means. Okay. So the news reporter said plus or minus 4%. Okay, what does that actually mean? So let's suppose that the proportion, the sample proportion was 0.60. So 60% of whoever was voting voted for candidate A. Okay, so if you say plus or minus 40, so if we change this to plus or minus 0.04, if your p hat is 0.60, okay, we leave a little margin of error. If this is this amount right here, that means it could be as low as 0.56 or as high as 0.64. Okay, think about that for a second. This is the amount of like error we're allowing. Okay, so what this newscaster or this newsman is saying is that that person's pretty confident that the sample proportion is between these two values. Okay, does that make sense? What we just did is this gap right here, this is what we call a margin of error. And you can flip back in your textbook to see where that is. Let me get there right now. It's kind of in the beginning. Page 436. Okay, so let's go back to our poop example. Poop. So let's say your sample, your observed time to go number 2 is 10 minutes. Okay, and someone asks you. Your nosy AP statistics teacher asks you, how long does it take for you to go number 2? And you're like, in your mind, you're thinking 10 minutes, but you don't want to say that, right? So you kind of give a range. It's kind of embarrassing. So you tell your statistics teacher 8 to 12 minutes. So what you just did is you observed of 10 minutes, okay? You said, okay, I don't want to say exactly 10 minutes, so I'm going to give an interval. There's that I word again. of 8 to 12 minutes. All right? And then this right here again is your margin of error. Your margin of error. We use the abbreviation ME as margin of error. Okay. Oh. Any of you have that nosy little brother, or nosy little sister or someone, right? Like, so they say you're doing your business, and your nosy little brother's like, I need to use the restroom. I need to go. I need to brush my teeth. I need to do whatever. I need to do my business as well. And your nosy brother banging on the door says, how much longer are you gonna take, or how long is it gonna take? And then you say, okay, it's gonna take 8 to 12 minutes, right? And say, what? I don't believe you. I think it's gonna take longer. And then you say back, how much do you wanna bet? How much do you wanna bet that I'll be done between 8 and 12 minutes, right? Like, think about that. How much would you be willing to bet? 10 bucks? 20 bucks? Chores for a week? Homework for a week? Doing his or her homework for a week? I don't know, right? Would you say like you are 100% confident that it's between this time? Or 90% confident or 80% confident? So that adds another aspect, another part to this confidence interval, okay? So now let's talk about formulas now. So let's go to page. Sorry about the talk about poop. Confidence intervals, okay? So we abbreviate confidence intervals as CI. The formula of confidence intervals is the estimate plus or minus the margin of error. And if I'm not mistaken, I think this is on your formula sheet. Not quite. It's gonna get a little bit more complicated. It's down here. So maybe if you wanna write down next to it, chapter 19 right here, confidence interval. So in the case of your poop, right, your estimate was 10 minutes plus or minus 2 minutes. Because you said 8 to 12 minutes. Hopefully that makes sense easily. Okay. So if you wanna answer it using that sentence frame, where'd that paper go? Remember this sentence frame right here from the formula sheet? You can say, I am, what percent would you say? I am 80% confident that the time it takes to go number 2, we'll keep this clean, go number 2, is between 8 to 12 minutes. Okay? All right, so let's practice this a little bit. We are gonna go to number, before we do that, let me just tell you a little bit more about confidence interval. Confidence interval depends on 3 factors. It can change based off of, in no particular order, your N, right? Your sample size. It could also depend on your level of confidence. Like how confident are you? Are you 100% confident? Are you 30% confident? Remember, confidence, just like probability, can only go from 0 to 1 or 0 to 100%, okay? And also your margin of error. Okay, so now we're gonna go see number 7 on page 446. So maybe we won't do 9 right now. Let's go to number 7. Let me turn the page, and you can turn there with me. Oh, actually, number 7, how about you just do number 7 by yourself? Yeah, it's like a true or false one. So do it yourself. Or how about you play Come On Down with yourself? Okay, so you you guess it, and then you reward yourself a responsibility ticket if you get each of those 4 questions right, A, B, C, and D. Oh, that would be fun. Let's actually do number 12 on page 447. And for this, I'm gonna change up the colors. Even though to me, all the colors look the same, but that's okay. Who cares? Cloning. We care about cloning though. Okay. A May 2002 Gallup poll found that only 8% of a random sample of 1,012 adults approved of attempts to clone a human. Wow. Seriously, guys, how do you guys feel about cloning humans? I mean, imagine a clone of yourself. Not only that they look, I guess Eric G kind of has a clone. No, maybe not a clone. But like looks alike, thinks alike, smells alike, thinks alike. Huh. Or would they? Or would they just look like you, but they would have their own personality? I'm not sure. So let's write down our given information. So we know that p hat is 0.08, and we know that n is 1,012 adults, okay? So that's important. So the first question asks, find the margin of error for this poll if we want a 95% confidence in our estimate. Okay. So we want to find a 95% confidence interval. So the formula for this, let's flip back. Let me give you page number, where is that? Okay, yeah, I don't know where it's at. Yeah. The formula for, what are we looking for, margin of error? I'm sorry, guys. Oh, yeah. So what you need to, I'm gonna write this on a separate sheet of paper and we'll come back to this. So the formula for margin of error is this thing times your standard error of your p hat. This is our first introduction to what we call a critical value, okay? Which is AKA number of standard deviations from the center, okay? So, oh, and this guy, you guys know this. This is on your formula sheet, right? This is the p hat times q hat over n. We did this in chapter 18. It should be this thing right here. Okay. Okay, so let's talk a little bit more about this critical value. And don't worry, we'll come back to the problem. So, yeah, it's in your textbook somewhere. I won't talk about page number. You can flip through and find it. So, if we want to find 95, let's say the critical value for 95%. What this is saying is, let's draw a normal curve. Okay, that normal curve is back. And 95%, we want 91% of our values to be within whatever these two cutoff points are right here. Okay. So what we're actually looking for is we're asking, what is the z-score right here? What is the absolute value of the z-score right here? So do you remember how you would do this? Think about it. Think about it. Okay. So if this whole thing right here, right? If this whole thing is 100%, what would this part be right here? What would this part be right here? This would be 2.5%, 2.5%, right? So what you're gonna do, you're gonna go to inverse norm of 0.025. And if I'm not mistaken, that comes out to 1.96. So that means the critical value for 95% is 1.96. In a second, we're gonna do 90%. So let's try it again. Critical value for 90%. So if we want this to be 90% right here, what would this have to be? That would have to be 5%, 5%, right? So you would do inverse norm of 0.05. And oh yeah, you're gonna get a negative value here, right? But we just wanna know the distance from the center, so we just make it positive. So this comes out to 1.645. You can round it right there. Keep these numbers in mind because we're gonna use them for number 12, okay? So back to 95 confidence interval. If we know that, looking for margin of error, sorry. The margin of error equals our critical value, our z critical value, times the standard error of our p hat. Since we're looking for 95% confidence, we already established that for 95% confidence, it's 1.96. So we know that this is going to be 1.96 times the square root of p hat is that, so q hat would be 0.92. So 0.08 times 0.92 over our n. Okay, go ahead and calculate that out and see what answer you get. While you do that, I'm going to go to the back and see the answer in the back. That should come out to 0.017 or 1.7%. Okay, so congratulations, you've calculated your first margin of error. Okay, if that's wrong, I blame, I don't know. Okay, let's go to B. B says, explain what the margin of error means. Basically, what this means, if you put in plain English, it's we will be off by 1.7%. Okay? That's in plain English. Or you can say that you are 95% confident that the true proportion will be between, will be off by plus or minus this amount. Okay? Look in the back of the book. Oh, you won't see that back in the book. All right, let's go to C now. If we only need to be 90% confident, will the margin of error be larger or smaller? All right. So I'm gonna go back to this one right here. Or, so let's think about this. If you don't have to be as confident, right? Would this, compare these two intervals right here. That's an interval and that's an interval. Which interval is smaller? I know my drawing is terrible and it's not to scale, but which of these two intervals would be smaller? Okay, obviously this one, right? Yeah, so if you're, as your confidence level, hold on. I need to be, yeah. Sorry. No. So it gets smaller. I had a brain fart right now. Sorry. Fart number 2, thinking my mind's in the potty. Oh, my mind's literally in the potty. So it gets smaller because as your confidence interval, as your percentage level of confidence gets smaller, then your interval gets smaller as well, 90 versus 95. So if you're like 10% confident, that interval would be really, really small. It would look, I don't know, really, really small like that. Okay. Question D. Find the margin of error for 90%. So this time we want to find the 90% margin of error. Okay. So margin of error, same thing, equals the critical value times the standard error of your p hat. So we established a couple of sheets ago right here that the critical value for 90%, and by the way, you can always calculate these using inverse norm, but we're going to be using many of these over and over. So, excuse me. Oh no, sorry. I kicked the camera. Right now we're just going to use this 1.645. So 1.645 times, well, we already did the standard error in the previous question, right? So let me look at that paper. That was this value right here. Okay. This should come out to, we said that our margin error would be smaller, right? So whatever our answer is should be smaller than these two values. And it should come out to 0.014 or 1.4%. And yes, percent or as a proportion is fine as well. Okay. Now let's take a look at E now. In general, if all the other aspects of this situation remain the same, would smaller samples produce larger or smaller margins of error? Okay, so let's think about this. Right now, the n we used was 1,012. That's pretty big, right? What if we cut that in half, like approximately half, and we made it 506 people? We would be less sure of our margin of error, right? So we want to make it larger. However, let's say, I don't know, we want to be extra sure, right? And we asked 10,000 people. So this one would make it smaller. Sorry, no, make it larger. If we took a larger sample, we could be more confident, right? We'd be more confident in our margin of error, so this would make it smaller. Like we could be more exact. So if you think about it, as the n increases, right, your margin of error gets smaller. And also inverse is true, is the n decreases and your margin of error gets larger because you're not as sure, right? You have less people going. Okay, so we'll stop right there.